So good morning, students. Myself, Vijay Shankar from AC Department, Chevrolet Engineering College. So today we are going to discuss about the binary adder and subtractor and look ahead carry generator. In yesterday's class, we already discussed about the binary adder and subtractor. It's nothing but a 4-bit adder and subtractor. Today also start with the same topic with the binary adder and subtractor with extension of next by using this look ahead carry generator. The look ahead carry generator is nothing but a fast adder. So by using the 4-bit parallel adder or it is a binary adder and subtractor, we'll get a propagation delay from each full adder. So to avoid or to rectify the propagation delay, we are going to take that it is by using a look ahead carry generator, nothing but a fast adder. Okay. Okay, see the student binary adder and the subtractor. So in this there is a 2 mode operations are there. That is m is equal to 0, the circuit is an adder. M is equal to 1, the circuit is in a subtractor. And see here, when m is equal to 0, m is equal to 0, when m is equal to 0, the b exclusive of 0 will get the b value. And the full adder receives the value of b, the input carry is 0, and the circuit performs the a plus b. Nothing but it is addition operation. The circuit performs the addition operation only. Okay. Now, when m is equal to 1, you can see the b exclusive of 1. B exclusive of 1. That is B bar, the full adder receives the value of B bar, the input carry is 1, and the circuit performs the A minus B, and circuit performs the A minus B. Following. Within the same circuit, it performs the addition operation by taking off m is equal to 0, and it performs the subtraction operation when it takes m is equal to 1. Okay. To perform these 2 operations, I changed that the binary parallel adder, the 4-bit binary parallel adder with exclusive OR gate. Let us see, this is the block diagram we have. Is a block diagram with having 4 full adders, full adder 1, full adder 2, full adder 3, and the full adder 4. Okay, and see the each full adder taking each full adder is taking off first LSB bits to the MSB bit. The first full adder, the full adder 1. The full adder 1 is takes the A1 directly. So directly it takes the A bits, A1, A2, A3, and the A4. But we have changed that it is only the subtrahend value, that is which is the B value, the A plus B and A minus B. Plus operation means directly take the 0 only. And minus operation means the Cin we can take the 1 value. Okay. Let us see here in the first full adder, I change the circuit for the B input and the another input as of mode operation, the M, with the 2 inputs of exclusive OR gate. See, when m is equal to 0, we are saying that as it performs the operation of A plus B, means Cin will get the 0, and m is 0, one of the input of exclusive OR gate is a 0, another input is from the B values, that is B1, B2, B3, and the B4. So first exclusive OR gate gets when taking off m is equal to 0 and the B1 as another input, the value is B1 only. So first full adder takes the A1 value and the B1, and the Cin is equal to 0. Whatever that we are given to the m is equal to 0 value. So after performing this full adder as addition operation by taking off A1 and the B1 and the Cn is equal to 0, it gets sum S1 and the carry C1. Sum S1 and carry C1. Okay. Then that C1 is given to the second full adder, and that second full adder is taking the another inputs A2 and the B2. But when M is equal to 0, the second exclusive OR gate also will get the B2 only. By taking off B2 exclusive OR of 0, we'll get the B2. So again, it performs the operation of full add addition operation by A2, B2 and the C1. It generates or it gives a response of S2 as a sum and carry is a C2. And carry is a C2. Okay. Then the C2 is connected to the next full adder, naming it as full adder 3. Full adder 3. And that full adder 3 is taking another 2 bits of A and the B, A3 and the B3. So the exclusive OR gate is connected to the one of the input is a B3, another input is a M. We are performing the addition operation. M is equal to 0. The B3 exclusive OR of 0, it becomes of B3 on. So taking off C2 as a carry, A3 and the B3 of the input values from A and the B. The full adder 3 is also performed the addition operation. It gets the S3 and the C3. Gets the S3 and C3. Okay. That C3 is connected to the next full adder, the full adder 4. The full adder 4. You see there? The full adder 4 also, it takes the MSB bits. That MSB bits are A4 and the B4. In the A and the B, A4 and the B4. And here also the B4 is connected to the exclusive OR gate, one of the input, and another input is M is equal to 0. So B4 and the M is equal to 0, it performs the exclusive OR operation, then it gives the B4 on. So the full adder 4, it performs the addition operation by taking off A4, B4 and the C3, it generates S4 and the C4. It generates S4 and C4. Okay, my dear students. Then finally, we got the sum is S1, S2, S3, S4, and the C4 is nothing but C out. That C out is a carry. Following. So an addition operation, the exclusive OR operation is exclusive OR gates, all the exclusive OR gates, the output getting the same value, B1, B2, B3 and the B4. Now coming to perform the subtraction operation by using the circuit, subtraction operation by using the circuit, the mode operation is M is equal to 1. I can take the M is equal to 1. When M is equal to 1, that M value is connected to all the exclusive OR gate as a second input. One of the input is from the B value, so that is B1, B2, B3 and the B4. But you can see in the LSB, the first full adder is getting Cn is equal to 1. Cn is equal to 1. Why is Cn is equal to 1? We are performing the subtraction operation, A minus B. So A minus B means, we know A minus B is A plus the complement of B plus 1. So changing of the B value to the 2's complement. First of all, it is a 1's complement means B bar. All the binary values changes from 1s to the 0s and the 0s to 1s. And add 1 to the LSB bit is converted to the 2's complement. So adding of A plus B bar plus 1 is equivalent of A minus B. The first bits, the full adder 1 takes A1 as a 1 bit, A1 as a 1 bit, and another bit is B1 bar. Why you are getting the B1 bar? That is the exclusive OR operation by taking of B1 and the 1. The mode operation is 1 now. B1 exclusive of 1 is B1 bar. B1 exclusive of 1 is a B1 bar. So the first full adder 1 performs the operation of subtraction operation. In that subtraction operation, it takes A1 as a 1 bit and the B1 bar and the C1 is equal, Cin is equal to 1. Okay, the full adder takes off A1, another input as a B1 bar and Cin is equal to 1. Now we'll get the A minus B, nothing but simply. Okay, so full adder 1 again gives a S1 and the C1. S1 and the C1. The second full adder FA2 taking off C1 and another two inputs A2 and another inputs A2 and the B2 bar. B2 bar. How we get the B2 bar? B2 with exclusive of 1. So second full adder takes the A2, B2 bar and the C1. It generates the S2 and C2. It generates the S2 and C2. Then that C2 is given to the FA3 and that FA3, another two inputs are A3 and the B3 bar. A3 and B3 bar. So B3 is one of the input of exclusive OR gate and another input is a 1. So B1 exclusive OR of 1 will get the B1, B3 bar. So F3, FA3, full adder 3 takes the A3, B3 bar and the C2 as the inputs and generates the S3 and C3. Okay, S3 and C3. I'm seeing here the C3 is there here and S3. It generates the S3 as a sum and C3 is a carry. C3 is a carry. And C3 is given to the FA4, nothing but full adder 4. It takes another MSB bits is there, A4 and the B4 bar. Okay, the output of the last exclusive OR gate is a B4 bar. A4, B4 bar and the C3, it performs the addition operation, it generates the S4 and the C4. S4 and C4. So using this circuit, we can perform addition operation as well as subtraction operation also by simple changing of B1 as a one of the input of the each full adder, convert as with the exclusive OR gate of one of the input and we can another input is connected to the mode operation and mode is equal to 0. B1 B exclusive OR of 0 is a B. It performs the addition operation and M is equal to 1. The B exclusive OR of 1 will get the B bar. Means all the input, all the bits of the B will get converted into the complement B bar. It performs the subtraction operation. Following. So that is the logical diagram of 4-bit binary parallel adder and the subtractor. Now you go for the another topic that is a look ahead carry generator. Look ahead carry generator. You see why we are going to the look ahead carry generator means it is also called as a fast adder. So by using the 4-bit parallel adder, parallel subtractor or 4-bit parallel adder and subtractor, you can see in each stage, every full adder is taking waiting for the carry of the previous full adder output. Means it takes some example, you can say the nanoseconds, let us. And the third full adder is waiting for the second full adder carry. And fourth full adder is waiting for the third full adder output of the carry. Okay, there is some delays occurs. That delay increases step by step from each full adder. So there is some drawback is there. It gets some delay by after get the output. So for this, to avoid that propagation delay, we are going for the look ahead carry generator. Is also called as a fast adder. Means the second full adder is not waiting with the first full adder output carry, and the third full adder is not waiting the second full adder output of carry. It directly taking off whatever the input carry is there, the Cin, all the full adder is depends upon the input carry of the Cn only. So how we can change this Cn values in terms of C2 in terms of Cn, C1 in terms of Cn, and C3 in terms of Cn, and the C4 is also in terms of the Cn. Let us see in the look at carry generator. The parallel adder, the speed with which an addition can be performed is governed by the time required for the carries to propagate or ripple through all the stages of adder. The look at carry adder speeds up the process by eliminating this ripple carry delay. It examines all the input bits simultaneously. The method of speeding up the process is based on the two additional functions of the full adder called the carry generate and the carry propagate. Okay, the method of speeding up the process. Whatever the delays occurs there in the full adder or the full adder, binary parallel adder, to speed up the process is based on the two additional functions of the full adder, called it as carry generate and the carry propagate. See, we already know the full adder is designed by using the half adders. Full adder is designed by using the half adders. Let us see this is the full adder circuit by using half adders. It requires the two half adders and the one OR gate. Hope everybody is visible the screen what I shared. Half adder 1 and the half adder 2. In the half adder 1 you can see there is a two inputs are there. The two inputs are AN and the BN. B suffix N. And the first full adder exclusive OR gate output is a PN and AND gate output is a GN. AND gate output is a GN. The GN we can call it as a carry propagate, carry generate, and the PN is a and carry propagate. That gives to the second half adder is there, half adder 2, one of the input of the exclusive OR gate, and one OR gate is also required to design the full adder by using the half adder. We can see the carry generate. The additional functions we have, that is a carry generate and the carry propagate. First of all, see the carry generate. Consider one full adder stage of nth stage of a parallel adder carry is to generate only if both the input bits are 1. Only if both the inputs are 1. Carry generate. AND gate means both the inputs is 1 only, that is then only generates a carry. Any one input is a 0, the AND gate output is a 0. Okay, when we'll get the carry is generate, both the inputs are 1. Let us see. In the full adder, we design that it is by using the two half adders and one OR gate. In the one half adder, there is an AND gate is there. From that AND gate, there is a carry is generated. Okay, by taking off two inputs. The two inputs are AN and the BN. Nothing but A and B. Let us see. A and B are the inputs. When it generates a carry, if both the inputs are 1, both the inputs of AND gate are 1, then only it generates a carry. Otherwise, it is a 0 1. Okay, that is, if both the inputs are A and B or is a carry, has to be generated in this stage, regardless of whether the input carry Cin is a 0 or a 1. Cin is a 0 or 1. Means a full adder having the 3 bits. In that 3 bits, Cin is either it is a 0 or 1, whatever it is, but the carry is generated when both the inputs A and B are 1 1. So irrespective of the carry there, if both the inputs are 1 1, then the carry is generated. If G is carry generator function, you can see in the circuit here, if G is the carry generator, I name it as here the half adder 1 GN. Okay, and that GN is equal to AN and the BN. Okay, I'm taking only simply there is a G is equal to A into B. the present bit as a nth bit, the present bit is the nth bit, then G rewrite as a Gn is equal to An into Bn. Following my dear students. So that is a first AND gate output, the carry generate An and the Bn by taking off the two inputs of An and the Bn. Then carry propagation, that is output of exclusive OR gate, P suffix n. A carry is propagated if any one of the two inputs, bits A or B are 0, any one of the bits A or B are 0, a carry will never be propagated. A carry will never be propagated. We already discussed about that. If any one of the input is a 0, the carry is not generated. Following. The carry is propagated if any one of the two inputs of the bits A and B are the 0. A carry will never be propagated. On the other hand, if both the inputs A and B are 1, then it will not propagate the carry but will generate the carry. It will not propagate the carry but will generate the carry if P is taken as B is equal to A exclusive OR of B. P is A exclusive OR of B. So when the carry is generated, any one of the input, both the inputs is 1 or. Okay, it is not propagated, carry is generated. The present bit is the nth bit, the P is rewrite as a Pn is equal to An exclusive OR of Bn. Okay. For final sum and carry outputs, you can see of the nth stage, sum is equal to Pn exclusive OR of Cn. You see in this circuit, the sum Sn is equal to, that is exclusive OR of another exclusive OR of gate output with one input is Pn, another input is there. Here you write here the Cn. There is a mistake here. So Sn is equal to Pn exclusive OR of Cn. Pn exclusive OR of Cn. Then Cn, nothing but the Cn is a carry. Cn is equal to, I am taking as a Cn plus 1. You see in the circuit, is a Cn plus 1. One of the input for the OR gate is a Gn and another input is from the AND gate. The AND gate inputs are, one input is a Cn, another input is a Pn. Means Cn plus 1 is equal to Gn plus Pn into Cn. Let us see the equation here. So Gn plus Pn into Cn. What is a Pn? That is a carry propagate. A Pn is nothing but An exclusive OR of Bn. An exclusive OR of Bn. Following my dear students, An exclusive OR of Bn. And what is a Gn? Gn is An into Bn. So finally the Cn plus 1 is equal to An Bn plus An exclusive OR of Bn into Cn. That is a Cn plus 1. Following my dear students. So based on these expressions for the carry outs of the various full adders, now I am taking that n is equal to 1. When n is equal to 1, or the n is equal to 1, first of all you can take it is n is equal to 0, my dear students. When n is equal to 0, rewrite this is not the n is equal to 1, this is n is equal to 0. Substitute here the n is equal to 0, C0 plus 1, nothing but C1. C0 plus 1, nothing but the C1. C1 is equal to n is equal to 0 means G0 plus P suffix 0 plus and C suffix 0. And finally, you see the final expression of Cn plus 1 is An, Bn plus An exclusive of Bn and the Cn. So substituting of n is equal to 0, it becomes of C1 is equal to, why it is C1? N is equal to 0 means 0 plus 1 is a 1. C1 is equal to A0, B0 plus A0 exclusive of B0 into C0. Okay, C suffix 0 that is. Then the second equation, the n is equal to 1, my dear student. It is n is equal to 1. Don't think that is n is equal to 2. N is equal to 1, then only the C becomes of C2. N is equal to 1 and this becomes of C1 plus 1 is a C2, that is equal to G1 plus P1 into C1. G1 plus P1 into C1. Okay. And what is a C1? C1 is nothing but G0 plus A exclusive NOR of B, or otherwise they take the first equation here, G0 plus P0 into C0. Substitute that C1 as G0 plus P0 into G0 plus P0 into C0, that is multiplied with the C1. That is multiplied with the, not the C1, P1. Okay. So finally you can see here the G1 is there, P1 is multiplied with the G0, P1 G0, and P1 is multiplied with the second term, that is P0 and C0, then it becomes of P1, P0 and the C0. Following? Take this, the C1 is equal to G0 plus P0 into C0 is multiplied with the P1 here. Okay, then the C1 with C2 becomes G1 plus P1 G0 plus P1 P0 into C0. And then when n is equal to 2 here, my dear students, not the 3a, n is equal to 2. N is equal to 2. So n is equal to 2 means Cn plus 1 becomes of C3a. So G2 plus P2 into C2. What is a C2? We got G1 plus P1 G0 plus P1 P0 and C0. You can substitute that and multiply with the P2. So see here, G2 plus P2 and the G1, because this total function is multiplied with the P2. So P2 with the G1 is P2 G1. P2 with the second term is P1 G0, P2 P1 G0, and P2 is suffix multiplied with the P1 P0 C0 is becomes of P2 P1 P0 and the C0. So total function will get after multiplying the P2 with the C2. And the last one we can see here, when n is equal to 3, my dear student, it's not the 4, n is equal to 3. When n is equal to 3, the Cn plus 1 becomes of C3 plus 1, that is a C4, and Gn is a G3, and Pn is a P suffix 3, and Cn is a C suffix 3. Okay. So now we can substitute the C3. Now we can substitute the C3 and multiply the P suffix 3. You see there, P suffix 3 with the G2 plus P suffix 3 with P2 and G1. P suffix 3 with the third term, we can multiply the P2, P1, G0. And P suffix 3 is multiplied, the last term is P2, P1 and C0. Okay. So the final expression of C4 when n is equal to 3, G suffix 3 plus P suffix 3 G2 plus P suffix 3 P2 PG1 plus P suffix 3 P2 P1 G0 plus P suffix 3 P2 P1 P0 and the C0. Okay, these are the 4 equations we got. When n is equal to 0, 1, 2, 3, you can substitute. You'll get as a C1, C2, C3, and C4. Now you can observe the C1 is depends upon C0 only, and C2 is also depends on the C0 only, and C3 is also depends on the C0, and C4 is also depends on the C0. Okay, it is not depends upon the previous carry. C4 is not depends on C3, and C3 is not depends on C2, and C2 is not depends upon the C1. All equations is converted into the C0 only in terms of C0. So the general expressions for the n stages is the Cn is equal to Gn minus 1 plus Pn minus 1 and the Cn minus 1. So no need of this one function. See all the equations what we got the C1. See the logical diagram of C1 is, let us see the C1 equation. C1 is equal to A naught B naught plus A not exclusive or B naught into C naught. This is the equation you can substitute in this. See the C1 is equal to G naught, not the G naught, P naught into C naught. P naught into C naught. You see this equation. This one. C1 is equal to G naught in plus P naught into C naught. G naught plus P naught into C naught. Directly you can connect it as a P naught, C naught as an AND gate, and G naught is another input of the OR gate. That is a C1. Following. And C2 is also, see the C2, what is the C2 equation? C2 is equal to G1 plus P1 G naught plus P1 P naught and C naught. How many AND gates is required here? For P1 P naught C naught with a 3 input AND gate, and P1 G naught is another 2 input AND gate, and is directly connected as G1, and all these 3 terms is connected to the OR gate. So see for C2, 2 AND gates are there. But our first AND gate is P1 G naught. So I connected the P1 and the Z naught. And second AND gate is 3 inputs. The 3 inputs are P1, P naught, and C naught. P1, P naught, and C naught. And third input is there. Directly I am connected to C1. So C2 will get. Like that, C1, C2, C3, and the C4 is a logical diagram. Logical diagram we have. And substitute this logical diagram in the block diagram of the look at carry generator. Look at carry generator. There is an IC, look like the IC here. So C2, C3, C4, and C5. Okay. And the C1, C2, C3, C4, like that. So directly we connect this internal diagram in terms of P4, P4, G4, P suffix 3, G suffix 3, P2, Z2, P1, and the Z1 is whatever we seen the previously the logical diagram. That logical diagram is totally inside this IC. Inside this IC. Following. So G1 and P1, let us see the G1 and the P1, and G1 and the P1 will get in this equation here, G1, P1. So for the C2, G1 and the P1. Now see, the G1 and P1 will get from the A1 and the B1 and C1 only. Okay. And finally that P1 is connected to the another exclusive OR gate here. That is second half adder. Second half adder exclusive OR gate. And P2 Z2 already is connected for the C2 with A2, B2, and the C2 is already there. And C2 with another P2 here. And P suffix 3, G suffix 3 by taking off A3 and B3 as the inputs. But C3 is in terms of C1 only. And similarly,